Hey Julian, welcome to this video lesson. We have 5 problems to solve, so let's get started. Day 1. A bag contains 12 green cubes, 8 red cubes and 4 blue cubes. You choose a cube without looking. What is the probability that you choose a green or red cube? Alright, so let's start by writing down the number of cubes for each color. So we have 12, G for green, and we have 8 R for red and 4 B for blue, right? So what's the total number of cubes? It's 12 plus 8 plus 4, that's 24. So we have the total number as 24. Now that becomes the denominator of the probability that we are looking for. And on the numerator, we need to have the number of green and red cubes combined together. So we have 12 and 8, that's 20. So the probability is 20 out of 24, and this obviously simplifies to 5 out of 6 or 5/6. It's a little blurry, but I think it's option D. Okay, let's move on to day 2. 2 out of every 20 boxes of Crunchios cereal contains a free gel pen. What is the probability that you will not find a gel pen in your box of Crunchios? Right, so for every 20 boxes, 2 boxes will contain a free gel pen, right? Now we are required to find out what is the probability of not finding a gel pen. Now there are 2 ways to do the problem. One is you could find out the probability of finding a gel pen and then subtract that number from 1, because 1 is actually the whole thing, you know, like 1 is everything. So 1 minus the probability of finding will give you the probability of not finding. The other way, of course, is to think of it like this. So if there are 2 boxes out of every 20 boxes that will have a free gel pen, then obviously the number of boxes that will not have a gel pen out of 20 is going to be 18, right? So you take out 2 from 20, you are left with 18. Now this is the number that do not have a gel pen. So then if you want to find out the probability that your box doesn't contain the gel pen, all you need to do is you just simplify this fraction, 18 over 20. So that becomes 9/10 or 90% or 0.9. You can write down probability in 3 different ways. Obviously over here the options are given as fractions, and it's going to be option H, 9 over 10. Done. Let's look at day 3 now. Maya made this net of a triangular prism. What is the surface area of the prism? Now a net is like if you open up a 3D shape, you know, you get areas. So you get a bunch of 2D shapes, and if you fold them up, you get back the 3D shape. So this is the opened up form of a triangular prism, and we need to find out the total surface area, meaning we need to pretty much add up the areas of this, and this together. That will give us the total surface area. So let me quickly draw this picture over here so that we could talk about the area. We could go ahead and find it. So then we have a 9 centimeter, it's this length that you see, and then we have a 10 centimeters, and it's the base of this triangle that you see over here, and then another 9 centimeters, and that's this length, right? So these 2 are equal. And then it's also given that the height of this triangle that we see over here, this height, is equal to 7.5 centimeters. And obviously the 2 triangles on the 2 ends have to be congruent in order to complete the 3D shape. Otherwise the prism will not close if these triangles were not to be congruent. So this one is also identical. We have a 10 centimeters over here, and the height is 7.5. Alright, so then the area of this rectangular portion that we see over here, we can easily figure that out. By the way, this is a 30 centimeter and we obviously need the length of the prism. So the area of this big rectangle that we see is equal to 30 centimeters times, we have this total length as 9 plus 10 plus 9. That's going to give us 28. So that's 28 centimeters. That's for the rectangular area. Now for the two triangles, we have, just as you know, the area of a triangle is 1/2 times the base. The base is 10. So we have times 2 times, 1/2 times 10 centimeters times the height, which is 7.5 centimeters, right? And then there are two triangles. So we multiply this with 2. Now 1/2 times 2. So this 2 and this 2 will cross off. So in the end, we have 30 times 28. That's going to give us 3 times 28 is 84. So this is 840 square centimeters. That's for the rectangular region. Plus the two triangles taken together is 10 times 7.5. That's 75 square centimeters. If you add them up, you have, I believe, 915 square centimeters as the total surface area. So that, I believe, is option D. Done. Paula drew a circle with 4 congruent circles inside it. If the area of the large circle is 167.2 square meters, what is the area of one small circle? Okay, now before we begin, I'm going to show you a cool way to solve this problem. Actually, there are different ways, but we are going to do it the smartest possible way. Now before we begin, I want you to recall that the formula for the area of a circle is given as pi times r square, where r is the radius. Yeah. Now if you look at this big circle and like 4 of these smaller circles fit into the big circle. So just a quick thought. Now if the diameter is twice the radius, right? So if the diameter of the large circle, let's say, is d, then obviously the diameter of each one of the smaller circles is going to be d over 4, or 1/4 of d. That makes sense, right? Because all of this is d, so that's divided into 4 equal parts. Therefore each one is going to be d over 4. Now because the diameter is exactly twice the radius, which means if the larger circle were to have a radius of r, let's say, then the smaller circles would have a radius of r over 4, or 1/4 of r. It's the same ratio as with the diameters. So we are going to take advantage of that. Look, so area of a circle is pi r square. So let's say that the area of the larger circle, the radius of the larger circle is r. So this is the radius of the larger circle. And it's given that this area is 167.2 square meters. So we could say the area of one small circle would be equal to pi times r over 4 and square of that, because the radius of the smaller circle is r over 4, right? So we do pi times, now r over 4 square, what's that? If you break this down, you have r over 4 times r over 4. A number square is the number times itself. And then if we multiply this, we get pi r square over 16. Now take a look at this and compare that with this. Now this clearly tells us that the area of one small circle is going to be exactly 1/16 of the area of the larger circle, right? And we know that the area of the larger circle is 167.2 square meters. It's given in the problem. Therefore, we could say the area of one small circle is simply going to be 167.2 divided with 16 square meters, and that I believe is 10.45 square meters, and that's option G. Done. Day 4 done. Over to day 5. The roof of the greenhouse, which forms half a cylinder, is covered in glass. What then is the surface area of the glass roof? So this is the glass roof, and we need to find the surface area of this roof, given that it's exactly half a cylinder. And the dimensions are of course given. The length of the cylinder is given, and the diameter of the circular portion, which is this one, is the same as this one. So that dimension is also given. We need them to find the surface area. Now before we go on to find the surface area of this greenhouse roof, let's quickly review the formula for the surface area of a cylinder, and then we can take up what should it be for half a cylinder. Now a cylinder contains two circles at the two ends, and the circles obviously are going to have their radii, and the radii obviously are going to be equal. So if this radius is r, this is also going to be a r. It can't be anything different, right? And if this is what we call the height of the cylinder, then the formula for the surface area, SA in short, is given as 2 pi r, that's the circumference of the circle, multiplied with the height h. Now that gives us this surface area of this curved portion. To that we need to add the area of the circular portion. So we have plus area of a circle with radius r is pi r square. 2 pi r square, because there are two circles at the two ends. Now we can actually customize this formula to suit our needs in this problem, and this is how we are going to do it. Now this is half a cylinder, you know, so the cylinder is exactly split through the middle. So then for the curved portion, we are not going to have 2 pi r times h, because it's exactly half of that. The 2 goes away. So we just have a pi r h for the curved portion. Now how about the circular portions? Now for the circular portions, as you can see, there's a half a circle at the top and half a circle at the bottom. So that's one full circle. So it's not going to be two circles as over here. It's just going to be one circle. So basically we drop the 2's from the formula and we get the surface area for the half cylinder. So let's go ahead and plug in the numbers. Now the height of this cylinder I have drawn over here. Now if you compare that with this cylinder, the height is this one, right? So that's a 45 feet. So surface area of the greenhouse, not of a cylinder, is going to be equal to pi times. Now the radius is the radius of this circle. Given that the diameter is 20 feet, then the radius is going to be half of that, which is 10 feet. So pi times r. So pi times radius is 10 times the height is 45. 45. That's square feet. That's for the curved portion of the greenhouse, plus pi times square of the radius. So that's 10 square. That's square feet for the circular portions. So let's add them up. 10 times 45 is going to be 450, plus 10 times 10 is another 100. So we have 450 and another 100 pi. So that's going to be 550 pi, and pi is, we all know, 3.14. So when we do this multiplication, that gives us the surface area in square feet. So this comes out to be 1727 square feet, and that obviously is option A. So that's it for now. I know you have to watch this video, understand the solutions, and run to school. So I'll catch you next week. Thank you.